In this video, I'm going to remind you how to write an explicit equation for an arithmetic sequence. Now, what is an explicit equation? Well, it's just a rule that states how to find any number in a sequence. And the explicit equation looks like this. You've got a sub n standing for any number in the list. You've got a sub 1, which stands for the first number in the list. And then you're adding to it the common difference times just one step back. So n minus 1 stands for the step number prior to the one you're on. Let's look at an example to see how you would write an explicit equation. The only thing you need is the common difference. I need the common difference to be able to get started, but I'll also need the template to the equation. So here I'm taking my first example where I'm asked to write an explicit equation for the sequence. And like I said, I need to find the difference between the terms. That's my common difference. It should be common throughout. To go from a 6 to a 10, I'm increasing by 4. To go from a 10 to a 14, I'm also increasing by 4. So since my common difference is 4, I'm really ready to write my equation. Now, go back to that previous step and remember what the equation looks like. The equation looks like this. A sub n is equal to a sub 1 plus d times n minus 1. Now, you'll be inserting the d, or the 4, in for the d, and then you'll also insert a number in place of a sub 1. Pretty much the rest stays the same. So your answer should look something like this. A sub n, standing for any number in the list, is equal to the first number in the list, 6, plus the common difference of 4, multiplied by one step back. Now, when I say one step back, I'm talking about one step back from the one we're on. We're not really even sure what one we're on because that's not what the problem is asking me to do. I'll talk about that in just a minute. So what I would like you to think is, this is the answer. You have just written an explicit equation for that sequence. Now, a lot of times we will simplify that equation, so I'm going to do that very quickly. 6 plus 4 times n, hopefully you remember distributive property, and 4 times negative 1. 4n minus 4. Then I'll put these like terms together and I'll say that the simplified version of my equation would be a sub n is equal to 4n, what's 6 minus 4? 2. So technically I could write my explicit equation this way in the simplified format or in my original format. Let's take a look at another example, and then I'm going to ask you to take it one step further. So we are going to write an explicit equation for the arithmetic sequence, but then we're going to use that equation to find the value of the 10th term in the list. So two parts to this. Remember, the first thing you have to do is find the common difference. So I'm going to ask myself, how is 12 turning into a 7? What am I doing to 12 to make it a 7? I think I'm subtracting 5. Let's just double check. Is 7 minus 5 equal to 2? Yes. Is 2 minus 5 equal to negative 3? Yes. So right now I know my common difference is a negative 5. Now I need that template to write my equation, and the template, remember, goes like this. A sub n is equal to a sub 1 plus d times n minus 1. That's my template. In my template, I'm going to substitute certain numbers, and those certain numbers come from my list. A sub n, remember, stands for any number in the list, but a sub 1 specifically stands for the first number in the list, 12. Now, you see where the template says plus d? I'm not going to write plus d because remember my d was a negative 5, so I'm going to write minus 5. And then in parentheses, this stays the same, n minus 1. So I have just substituted only my a sub 1 number and my common difference. This is the answer to the equation. However, like I said a minute ago, you can simplify it, so I'm going to do that. 12 minus 5n plus 5. Hopefully you know where I got the plus 5 from. Just distributing my negative 5. The simplified version would be negative 5n plus 17. Now, I was asked to do two things in this problem. Not only write my explicit equation, which I did, but I'm also asked to find the 10th term in the list. My list only consists of 4 terms. 12 is the first one, 7 is the second one, 2 is the third one, 3 is the fourth one. I'm interested in finding the 10th number in the list. But I'm not going to keep subtracting 5. I mean, I could just keep subtracting 5, but it's just not prudent. What I'm going to do is I'm going to substitute the number 10 in for the n number, because n stands for the step number that I'm on. So I'm going to take my explicit equation, a sub, I'm not going to write n now because I'm interested in the 10th term in the list. A sub 10 is equal to negative 5. Now instead of writing an n, I'm going to write a 10 because n is standing for 10 right now, plus 17. So I'm going to find the 10th number in the list by multiplying by negative 5 and then adding 17 to it. 50 minus 17 is a negative 33. So the 10th number in the list is a negative 33. Okay, now you try. Pause the recording and write down this list of numbers, these 4 numbers, write an explicit equation for it, and then find the value of the 20th term. Then come back and look at what I did and see if our work matches. So remember, I'm going to start by finding the common difference between these values. It appears that I'm adding something to negative 8 to get to 3. I'm adding 11. 3 plus 11 is 14. 14 plus 11 is 25. So my common difference is 11. What do I do with that common difference? I put it in place of d in my equation. The template for my equation, remember, is a sub n is equal to a sub 1 plus d times n minus 1. I'm going to insert certain numbers where they belong. I'm going to put the first number in the list, negative 8, in place of a sub 1. I'm going to put 11 in place of d. Everything else stays the same. So a sub n is equal to negative 8 plus the common difference of 11 times n minus 1. This is the explicit equation. I could leave it like that, or I could simplify it, which I'll do because it's good practice. Negative 8 plus 11n minus 11. Simplify it further, 11n minus 19. Could be my simplified version of the explicit equation. Both of them are acceptable. So that is the explicit equation. But then you're going to use it to find the 20th term in the list. So here I go. The 20th term in the list. Remember, this one's my first one, this one is my second, my third, and so forth. I want the 20th. So to find the 20th, I'm going to take my explicit equation, a sub n. Instead of writing n, I'm going to write a 20 in the n spot. And I'm going to take the first term in the list, negative 8. To it, I'm going to add 11, and then n minus 1, 20 minus 1. If I simplify this expression, I'm going to find the 20th term in my list. Let's not distribute this time. Let's do this. What's 20 minus 1? 19. And then negative 8 plus whatever 19 times 11 is. 209. And then negative 8 plus 209 is 201. So the 20th number in the list is 201. If we started with negative 8 and kept adding, then the kept adding the 11, and we did it 20 times, the 20th number would be 201. All right, now let's take a look at an example where we're going backwards. This time you're given the explicit equation, and you're asked to generate the first 3 terms of the sequence and then find the 12th term. So, looking at my equation and remembering what my template looks like, 18 is the first number in my list. -6 is my common difference. So to write my equation, or to write the first 3 terms in the sequence, I'm going to start with 18. I'm going to subtract 6 from 18 and get 12. I'm going to subtract 6 again and get a 6. So the first 3 numbers in my sequence are 18, 12, and then 6. Now if the sequence continued and I wanted to find the 12th term, the way I'm going to find the 12th term is to just insert the 12 in place of the n and then calculate it. So it'll look something like this. The value of the 12th term in my list is found by taking 18, subtracting 6, 12 minus 1 times. So 12 minus 6, 12 minus 1 is, did I say 12 minus 6? 18 minus 6 is equal to 12 minus 1, and I got lost there. 12 minus 1 is 11. 18 minus 66, and whatever 18 minus 66 is, that's the value of the 12th term. So using my calculator, I just got -48. So the 12th term is a -48. Had we kept subtracting 6 all the way down the list, the 12th term would have been a -48. All right, now you try. Take the explicit equation I've given you, find the first 3 terms in the sequence, and then calculate the 25th term. Pause the video, work it on your own, and then replay and check your work against mine. Okay, looking at this explicit equation, I can see that the first term in the list, is a -3. As I go down my list, I'm adding a half. So -3 plus a half is equal to a -2.5. If I add a half again, I'm going to get a -2. So the first 3 numbers in my list are -3, -2.5, and -2. But if I want the 25th term, the 25th number, then I'm going to insert 25 in place of n and calculate it. So the value of the 25th term is found by taking the starting number -3, adding 1/2 to it, n minus 1 times. So -3 plus 0.5 times 24 is equal to -3 plus half of 24 is 12. -3 plus 12 is 9. So if I had kept going down the list by adding 1/2, adding 1/2, adding 1/2, I would have ended up at 9. The 25th term is 9. So for a quick recap about writing an explicit equation, let's change this up here. For writing an explicit equation, nothing like copy and paste. The purpose of it is to help you find any number in the list, like what we were doing, finding the 10th number, the 12th number, the 25th number. That's why you want the explicit equation. The recursive equation is good for just finding the next term in a sequence. That's why your explicit equation is so wonderful, so powerful. You'll also need to remember what the language looks like in terms of the symbols. So I've been working with, again, this form of the equation, a sub n is equal to a sub 1 plus d times n minus 1. But keep in mind, you could also use function notation to stand for the same thing. F of n acts just like a sub n. Both of them stand for, let me finish writing function notation here. Both of these guys stand for any number in the list. The a sub 1 and the f of 1 both stand for the first number in the list. And then your d times n minus 1, d times n minus 1 both represent the common difference times one step back. So now you know about explicit equations for arithmetic sequences. Good luck!